Hello everyone and welcome to World Science Festival Brisbane 2021. Let's hear it for science. Let's hear it for Science Live. I mean, the World Science Festival 2020 was canned because of COVID, but you know, we're just sneaking through. We're just punching the edge of it this year and we have made it through to the end. So it's a huge relief and a wonderful thing for us to be here, not on Zoom, not with screens, seeing and hearing people live and in the flesh. And today we've got a terrific illustrator for you. Do we have any illustrators here in the audience? I don't know why I'm putting my hand up. Do we have any? Yeah, okay, or you're all a bit shy, that's okay. But we've got an amazing illustrator who I'll get to in just a moment, but I do just want to begin by acknowledging the traditional owners of the land that we're meeting on today and that the festival is taking place on, and paying my respects to their elders past, present and emerging, and also acknowledging the first scientists of Australia. Our First Nations people were our first scientists, and that's being recognised in more and more scientific fields, the role that our First Nations scientists continue to play in our emerging sciences. So I'm Bernie Hobbs. My background is as a science reporter and writer at the ABC. I mean, I can draw a little bit, but nothing like the guy we're going to see here today. So Jeff Thomson, not the fast bowler, the other Jeff Thomson is an award-winning scientific illustrator from the Queensland Museum, and Jeff has been at this gig since 1982. So for people who are millennials, jobs back in the day could last for more than 6 months at a time. Unfortunately, that is truly a thing of the past. But thankfully for us, Jeff's been here through the age of hand drawing, through the age of printmaking, through the age of etching, right through to the age of digital photography. And he's won awards for various stages. And he's actually had a work of his turned into an artwork that's been hung in a little gallery called, the Tate. So pretty impressive stuff. The way we're going to work it here today, Jeff has got some extraordinary slides of the work that he's done and the story of scientific illustration throughout the ages. But luckily, he's also got some beautiful original versions of those works, so you'll get to come down the front and see those later on. So for about the first 35 or 40 minutes or so, Jeff will talk us through the story of scientific illustration right from the get-go. I'll probably interrupt him with a couple of questions just because I'm incredibly nosy. And then after that, we'll get to your questions at the end. So whatever your questions, Jeff's up for answering them. I really hope you enjoy today's session. The sessions we've had in here have just been beautiful. So lots to see, lots to think about, and lots of time for you to have a say as well. And also a special thanks for coming out when things have been a bit up and down with COVID in the last couple of days. We really appreciate you coming and joining us here. So that's it for me. A big warm welcome to Jeff Thomson. And now, Jeff, I know you've been at this gig for, almost 40 years now, but scientific illustration has an even longer history than you do. So would you start us off with where scientific illustration began and tell us a bit about the different techniques and methods through the ages?
Thanks, Bernie. Yes, scientific illustration, from what I can see, began in late Roman times. You'll see this image here. It's from a Byzantine manuscript that's preserved in Vienna from circa 512 AD, and it's quite an accurate image of a bramble. But these things, medieval herbals and bestiaries were also early starts of scientific illustration, but a lot of them were fanciful. You can see a mandrake here, just like out of Harry Potter.
Nothing fanciful there.
And you can see some of these animals, I think they're meant to be lions, but not very accurate. And there's lots of scientific, some changes, technological changes have influenced how scientific illustrations have been drawn and reproduced through the centuries. And there are many famous artists who worked either directly in the field or on the edge of the field, or whose works are so accurate that you consider them scientific. And there's many different drawing techniques through time and reproduction techniques through time. So in Europe, the earliest scientific illustrations are woodblock prints. And that started in about 200 AD in China, but it came into Europe in the 1430s, but it wasn't used in scientific illustrations till a bit after that. But the printing surface of a woodblock print sits at the top and the rest of the wood is carved away. So that's one way of printing. And then we have intaglio printing, where you either you make a groove or a pit in a metal plate, and then you force ink into those grooves, wipe the excess off, and put it through a press with damp paper and felt blankets to transfer the pressure, and the paper actually goes down into the grooves to transfer the image.
And is that intaglio, does that give you more detail or just longer lasting?
Yeah, it's more detail than a woodcuts possibly, although later there's wood engraving, but at the stage we're talking about, the woodcuts were relatively crude. And then there was etchings, which developed, I think, from armoury, where they were etching patterns onto armour, and you used acid to take away the metal instead of having to. If I go back for a minute, you can see this guy here, he's pushing a burren, which is a V-shaped tool, and he's actually pushing it to cut a groove in the copper, whereas etching is a lot less physical. And this is stipple engraving. The one on the left is by Redoute, and this is from Lacordaire. I'll talk about Lacordaire later. But it involves lots of tiny pits, little dots engraved into the surface of the copper to give you tone. There are lots of other ways of making tone, like aquatint and mezzotint, but mezzotint was hardly used in scientific illustration. But tone coming from metal plate was a real problem for people in the early days.
So do you mean the more stipples there are, the more pits, the deeper the colour, the richer the colour
in that area?
Yeah, the blacker,
and you can see the beautiful rendering of the leaves and petals in there.
Stunning.
And then there's planographic printing, with lithography is the main one. And at the time, we're talking, most of this was done on actual blocks of limestone. Well, all of it was done on blocks of limestone. And you have a polished block of limestone and you draw with a greasy crayon on that block, and then you open up pores in the stone with acid, and the crayon protects the bit that you've drawn on. Then you treat it with gum arabic, which absorbs the water, wet the stone, and then you roll greasy ink over the surface of the stone, and that printing ink sticks to the crayon, or sometimes you use ink as well, and then you are able to print it. So that's black and white printing. And a lot of these things were black and white and then hand coloured from a master painting on every copy of the book by a team, usually of women, working from a master painting. And then there's chromolithography, where it was developed in 1837, and it involved multiple stones printing different colours. And you can imagine that's quite difficult to get every print in the same position, registration we call it. You can see in this example they've got a little bit out, but a lot of it is beautifully done. Then there's colour halftone printing, and also black and white halftone printing, where they used a photographic dot screen to break up the colours and print that way. Pretty modern. Now this is work by the great Frank Nanninga in Canberra in the 1960s for the Insects of Australia, and I've seen actual plates from that book, which was and still is the Bible of Australian insects. And when I first saw these images, I thought they were photographs. But what he's done is used stipples or scraping to create a total black and white drawing that can be etched into the acid, with acid, into the zinc. And that's what, I don't know if there's illustrators around, deep etching really means that, taking away the zinc.
So for something like this, if you got 3/4 of the way through it and then just went a bit too hard in one section, is there any way of undoing the stippling?
Well, scraper board's very forgiving.
Okay.
You get about 4 or 5 stuff-ups that you can fix.
Okay. Good to know.
Yeah, it's very helpful. And now we've got digital publishing. This is a website, and this is a PDF of photographs I took, but that's from the Memoirs of the Queensland Museum, and it's produced as a PDF. Sometimes it may in the future not be printed at all, but that's where we're going with that.
So that different use is calling for different methods to be used, I guess. And you were talking about the book that was the Bible of insects for, I didn't know they were a religious species, but, the Insect Bible. But we've got a phenomenal collection in the Queensland Museum library of different books of scientific illustrations. Can you tell us a bit about that and like the oldest? And
Yes. So, yes, when I started work at the old museum, you walk down this corridor every day to the entomology building, and this is when we were moving. I took this photo, but the library spilled out of the main library room right down the corridors, and there were fantastic hand-coloured books right outside our door. And it's a treasure trove of wonderful things. You can see that goes back to 1791. And we've got other journals and rare books. It's a fabulous
And they're
book.
still in the collection now?
Yep, upstairs.
How does someone get access to that?
You have to have a good reason to be researching
What
it.
about I'm a Mate of Jeff's?
Maybe,
Yeah.
yeah. And this is from our oldest book. I find it charming and funny. It's an orca. And you
Clearly.
can see that the artist probably never saw an orca and was trying to illustrate it. And this is a woodcut, and it's from the first great book on sea creatures, published in France in 1554.
Wow. Oh, if we can hold off the questions until the end. Yeah, sorry.
So
I'm just being rude to you because I know your family as well. So
when they had a crab in front of them, they were very accurate. And a lot of the illustrations in the book are very accurate, but it's when they're trying to draw things. And there's actually, I didn't put them in, but there's a thing called the sea bishop and the sea monk, and they're hilarious.
Oh, they actually, yeah.
Yes.
Got their little mitres on. And
pretty cool things.
Yeah.
Oh, sorry, wrong one. And this is this book is a 1758 English translation of work done by the great Dutch microscopist Swammerdam. He was a contemporary of Van Leeuwenhoek, and so this work was actually done in the 1600s with some of those fantastic, or some of those really primitive microscopes. And Swammerdam's work is well known to most entomologists. And these things, the book is that long, they're great copper engravings, and you can see he's dissected a bee's eye and the mouth parts of a mosquito and things like that. So fantastic work for the time.
it's phenomenal.
Yeah. This is one of my favourites. This is Kramer. It's one of 4 copies that I know of in Australia, and it's from 1779 to 1782, if I remember rightly. And these are the frontispieces where the artist was allowed to have a bit of a free rein. And I didn't know for ages that this one was behind that one. And you can see in this, there's various works of the time, like Linnaeus and Sibylla Merian, and these little putti are bringing butterflies in old-fashioned collecting cases, and there's drawing equipment and drawings in the front. So
How do you mean, sorry, it was behind it in the book? Or?
yes, it was the next page, and I didn't see it for years. A bit of a worry. But every 3rd or 4th page in this 5-volume work is a hand-coloured engraving of butterflies or moths both.
Stunning.
And it's an incredible thing. Each volume's about that thick, most of them, and incredible. And we also have the only deluxe copy of Drew Drury's Insects in Australia. This is the famous image of a Goliath beetle drawn by Moses Harris. It's rare for the artist to be actually acknowledged properly, but anyway, that was shown. The beetle is in fact about that long.
Wow.
And it's a great image.
Where's it native to?
It was found floating in the River Gaboon in Africa.
Okay.
This is Lewin, who many people will
Yeah.
have heard of Lewin's honey eaters.
Yeah.
And Drury actually sponsored Lewin and gave him copper plates to bring to Australia. I think they were lost overboard or something, but
No.
eventually he made these etchings, and these are the first etchings done on the continent of Australia.
Wow.
Ours is the second edition, but it's better coloured. It was after he died and produced in London under his wife's direction. Oh, sorry, trying to get this to go. And this is La Cordaire that I was talking about before. These are stipple engravings, and you can see the stipples there that's a blow up of that structure. There's 134 plates. Each one has 4 or 5 beetles in natural size, and they've been printed with dolly wiping of coloured inks into particular beetles, and then hand coloured with watercolour, and they seem to have a varnish on them as well. And it's a fantastic work.
How well, like those photographs we're seeing there, is that a contemporary photo of? So they've held their colour that well.
Yes,
the books
yeah,
you've
I
got,
took I've taken all these
Wow.
photos. Yeah, these by Helena Scott, the Scott sisters. Many of you will know of. They're heroines of mine, Australian illustrators who were working on Ash Island in Newcastle, working on their father's book on Australian Lepidoptera life cycles, and they were actually going out in the bush and finding these things and drawing them from life. And there's a detail of a Joseph's coat moth, and they also did snakes for Krefft, Snakes of Australia, Krefft. And this is Edward Lear, who did The Owl and the Pussycat and Nonsense Rhymes. He taught Gould how to do lithography, but sadly Gould actually expunged Lear's signature from some of his plates.
How rude.
Not very nice.
Gould used to be a hero of mine.
Yes. Gould didn't draw much himself, but Lear was wonderful at drawing. These are actually living birds in a aristocratic menagerie that he was drawing from. But you know, you can see this is Richter drawing them for Gould, as is these. These are some of the finches and the Queen Victoria's rifle bird. And another great artist that's represented in the collection is Ernst Haeckel. I'm not sure if my pronunciation is right, but this is from a multi-volume work, The Voyage of HMS Challenger. It went round the world doing deep-sea trawls from 1873 to 6, I think. And it's a fantastic repository of images by many artists. And they also dissected a thylacine, which blew my mind.
Wow.
But, you know, at least we've got something like that. And this is from Bleecker. Now, these are chromolithographs, like I was telling you about before. But you can see here the registration is perfect. And Bleecker apparently was an amateur working for the Dutch East India Company, and he started to collect fishes and illustrate them, and it's just a magnificent work, multi-volume and incredible tropical fish from Indonesia.
It's a spectacular collection. We're really lucky to have it here
Yes.
at the museum. Not that any of us will ever see it, but it's great to have it there as a reference. But when you started work here, almost 40 years ago, Jeff. You're very well known as a photographer now, but the illustrations that you were using at the start, what kinds of techniques were you using?
Well, I started even before I started work here. I started in 1975, and I was taught a traditional scraperboard technique in the tradition of Frank Naninga. I learnt from Sybil Curtis, who gave me 2 one-hour lessons as I was working for Tom Woodward as a research assistant out at the University of Queensland.
So 2 one-hour lessons.
That's right. But I got critique over the time and developed that way.
And is that the...
That's
is that
the
from
last
75?
drawing I did. Yeah, so it's a later one. But we used a camera lucida, and I'll just turn and show you. So this is the camera lucida coming out the side of the microscope, and in that housing is a silvered mirror that's silvered on the outside, and there's a system of prisms and mirrors, prisms and lenses in there that you can focus on your drawing at the same time as you're focused on your specimen. This little lever engages and takes it out, and by adjusting the light on your paper against the light on your specimen, you could see a shadowy image of your hand and your pen or pencil.
So, sorry, are you're
tracing.
always looking down the microscope?
Yeah, and you can see, and you're tracing.
Wow.
Because you had to get it absolutely accurate.
Yeah.
It couldn't be, it had to be measurably accurate.
Wow.
So that's just a picture taken at the time looking down the eyepiece of a microscope, and you can see that. So you can see that a lot of it isn't in focus. It's not very clear. So we just couldn't take photos back then. So we had to focus up and down and get everything in focus by hand. And because you have a 5-degree angle on the eyepieces, the drawing moved from side to side, so you couldn't tape it down as some people did. And you had to have reference points every time you focused down. You had to have something that was still in focus enough to line up the drawing again. It's quite a job.
Yeah.
And this is a rough pencil outline, and we would fold that down the middle and take the average of the 2 lines and line it up, and then make sure you hadn't distorted it, and then put the limbs and antennae on, and then we would use the old map making technique that us older people used to do at school and transfer it with a pencil to scraperboard, or what the Americans call scratchboard. And it's white, the white stuff that we used. You can't buy that in Australia anymore, you have to order it from overseas. But it's a sprayed on white kaolin clay surface, and you can paint the dark areas, and anyway, but you ink it in first with a multiple clogging rapidograph, and then you map out the dark areas, you paint them black, and then you stipple the light areas with a pen with lots of dots. And this is a video of me. It's not my best stippling, but it gives you an idea. It's gone a little out of focus, but you can see what's happening. So I stippled in a pattern of 5, and the box of 5 with 4 with a dot in the middle. And by mentally expanding that box, you can evenly bring the dots out to get lighter.
That's so funny. I was going to say, it seems really meditative, but actually it seems very mathematical now. And there's a lot of calculating.
And then you use a little scraping tool, and the area I've painted black, you scratch little reverse stipples, and everywhere you scratch it, it comes up white again, and you can blend the shading.
Oh, nice.
It creates a bit of gunk, and you'll see me blow it away at the end.
And so that beetle work that we saw, how long would that have taken you to produce the full, complete image?
Some of them, much to my old boss's chagrin, took 3 weeks, but
hey, if you want the award-winning illustrators,
usually a week. Sybil was much faster; she could do one in a day. I don't know how. And Frank Naninga apparently did one a day, but that was a terrible toll on him, and he was in fact taking work home and working till. This is stippling to an antenna to show how it, and you can see once you've done the denser stippling on the edge, that it's quicker to blend it. I'll go to the next one. So that's scraping the dark areas to blend with the stippled lighter areas, and that's drawing in the hairs at the end. And there's a nice little photocopy animation here. That's the finished image. This was a darkling beetle from New Caledonia, and you can see how it happened.
Beautiful.
Thank you.
Wow, and that's his drug-addicted cousin over there.
So I did this till 2004, and this is just to show you the difference between the illustration and photographs of the actual beasts.
Oh. Can we just go back and forward again?
Yes.
Wow.
I'm not sure that's the actual specimens I was drawing from, but they're the same species. And there's a couple more. That one that's in fact about that long, the termite. It was done for Kakadu.
And you've got that. Oh no, there's a different one.
No, that's another one in the series. The Queen is there that you can have a look at. And then there's this watercolour here, which I did in my own time. I couldn't do watercolours at work. That wasn't part of the brief. And but this one was a commission for as a memorial to Frederick Athol Perkins, and he was a great fruit fly man, and it was commissioned by Dr. Dick Drew, who's also a great fruit fly man, and it was commissioned. I got $400 for it in 1989, and it took me 100 hours of work with a brush. Everything's done with a brush.
So it's like the normal gig economy.
Yeah, that's right. Yeah. So you can see the detail. That's all done with a sable hair brush.
Wow. So you obviously did some spectacular drawing in the earlier days, but you stopped drawing in 2004 professionally. So do you still draw? Obviously you don't mind doing the fruit fly in your own time. Back in the day, do you still draw in your spare time?
Yes, I'm a printmaker now. I've been doing that since 1998, and it's given me a lot of insight into how those old illustrations were done in the library. And so the basic I do etching, and these are just a quick glimpse of it, but you draw through a ground with a needle usually, and the ground is a mixture of bitumen and waxes, and where you touch it with the needle, it exposes the bare metal, and then you put that into nitric acid and it eats down into the metal plate, and you get all these pits and grooves in the metal plate. You wash that off with turpentine, then you force greasy ink down into those pits and grooves, wipe the excess off with old telephone book. That's a press, and that's a simple etch. Well, not a simple etching, but it's a line etching, and that's wiping off a complicated inking of a plate, and you wipe away to try and not pollute the rest, and then you roll it through the press, and then you eventually pull a print, and that's the finished print printed from 2 plates with 4 colours, and then some hand colouring with watercolour added, and that's the original over there.
Oh, beautiful. But for your day job, you had to, like so many of us, learn how to go digital.
Yes.
So how did you go about that transition? Because it's a very different world from stippling.
Yeah. Well, I was very lucky. I got a Queensland Smithsonian Fellowship and got to work with Marie Metz here in the National Museum of Natural History in Washington, D.C. I had 15 weeks fellowship, and 13 of those weeks were working beside her. And every time I got stuck, anybody that's worked in Photoshop knows when you get stuck, you need an expert beside you, and she was wonderful. And I learned how to do this sort of illustration from scratch, and there's a nice little animation of it too. That was one I did when I got home. This is Kanaka which is from New Caledonia, and that's all done with a mouse. It took 3 weeks.
Wow. And why
Yeah.
with a mouse instead of a
Because she reckoned that
stylus?
the hairs, I couldn't get those nice curves in the hairs with a stylus, but it's not something I do much anymore.
And so now you're not doing this kind of illustration anymore. You're actually doing photography, but a
Yeah,
particular type.
That's right. So now I take focus stacked photographs, and I use some of the techniques that I learnt in the Smithsonian for doing things like taking out pins and cleaning up dust and things like that.
So just what is focus stacked photography?
Focus stack, you take a whole heap of photos, digital photos, from top to bottom of focus. So you really got to find the top and the very bottom, and you take them at regular intervals, and there are programs, stacking programs, that take all the sharp pixels out of all of those photos to give you one sharp image.
Wow. Nice.
Yes, it's an amazing thing. So this is before I photoshopped it, and that's after. So it makes a huge difference, and my illustrative techniques really make a big difference to what I do. This is our wonderful system. It's had lots of upgrades over the years. We're currently waiting on a new computer which will have a 64-core CPU, which and other wonderful things about it. But it's wonderful, and it's developed since 2012 when we first got it. And we use a 50 megapixel Canon camera with Canon lenses to take macro shots, and that's what we get.
Wow. And is that colour that you've added later, or that's wow.
The colour. That's true colour.
Wow.
Yes. And now we have these beautiful Mitsutoi lenses, the higher magnification Mitsutoi microscope objectives can resolve 0.7 of a micron, which is pretty insane. But Roy came up, the guy who built my system from America, he came up with this system of putting an adapter he bought from some dodgy person in Russia and on a 200 millimeter telephoto lens set to infinity and wide open, because if you close it down at all you get bad vignetting around the edges, shadows around the edges. And but with this setup, it fills the whole 50 megapixel sensor. We didn't have that in the beginning.
Wow.
But this is taken with a 20 megapixel camera with the same lens, and you can see the grooves in the Theta there, which is incredible. And there's lots of wonderful things we've been able to take. That's a Christmas beetle. This is a close-up picture. And you can see the detail you can see in these images is astounding.
Yeah, it's almost getting to the point like the scanning electron micrography.
Yes, we can rival it sometimes.
Yeah.
I want you to look at that little bit.
Wow. Okay, that looks like pasta on the right.
Yes, they do look like pasta.
That's phenomenal.
So yeah, it's amazing. And see those grooves there?
Yeah.
I could be wrong, but I believe that they're part of the structure that's breaking up the colour to produce that blue.
That's right. It's not in butterflies, or
it's
I assume
structural.
in moths it's not pigment.
It can be both, but
okay.
because those pasta ones, they're pigment.
Okay.
But this is a structural colour.
The iridescent
colour. Yeah, that's right.
Yeah.
And we also do tiny land snails. And when you were talking about rivaling electron microscopy, see that line is 0.1 of a millimetre, and you can see all sorts of microscopic detail there. So when we had just a 20 megapixel camera, sometimes they'd want big megapixels to print. And so I would take I'd take multiple stacks. So this was done from 4 quarters and a couple of hundred shots in each one, and then merged in Photoshop sideways.
How often does your computer crash?
Fairly regularly. Yes. So when we did the first version of this at a smaller magnification, Brian Lassard, who some people will know as Bri the Fly Guy, he came up, and this was one of his species he was working on. He said, "I have never seen the receptors in the antenna before, let alone be able to tell that there are 2 different sorts."
Wow.
So it really is incredible what we're able to see in these things. That's a detail of that shield bug that I showed you that I'd done the Photoshop on before. And you can see that. We can zoom right in. That's once again 0.1 of a millimetre. It's really astounding. We just couldn't take these pictures, 5 or 6 years ago.
Wow, even that recently?
Yeah, it's just amazing. Not at that magnification. And I do some fossils mainly for Andrew. And so this is an Equisetum, which was it's the latest in the fossil record that's been found in Australia. So that was pretty special. But it's a nice beetle elytrum, a beetle wing case in the same formation.
Wow. And
this is one of the awards that I managed to, I got a highly commended. Gary won that year. But in the Eureka Science Photography Prize, which they no longer hold, sadly, so I've never been able to enter it again. But this was taken with the old microscope. It's a parasitic wasp embedded in Australian amber. They don't know the source of the amber, so they're guessing that it's about 10 million years old, but they're not sure. And that's the detail we were getting with the old microscope.
And that's through amber?
Yes, that's right. But this is what we can do now.
Wow.
And
you need another award category.
Yes, I keep hoping they'll bring it back. And you can see the detail that's there. So, yeah, it's truly astounding what we can see. And this is fossil Casuarinaceae, relative of Casuarina pollen. I'm not sure exactly how old it is, but it actually had fossil pollen grains in it.
No way.
Which is astounding to be able to see in colour. Roy gave me a special toy where it has a black velvet background and a little pillar with he's reamed out a well in the top that you can put the wax in that holds the butterfly pin. So you get wonderful pictures of butterflies with black backgrounds. And you can see that's not been photoshopped, that's just the black background that came out. It's fantastic.
Stunning.
This is another species. Fantastic detail you can get. And we've done a lot of ants, particularly Chris Burwell's there's been a project to photograph for the federal government all these different nasty ants that could get into Australia and cause us problems, so that people can identify them if they turn up. So this is Myrmica rubra, which is the European red ant. That's a big problem, I gather, in North America already. And that's the detail. I always think it looks like a blackberry, that eye.
Wow.
And that's a side view. And that's the green-headed ant that bites you in your lawn.
Not a green ant?
Yeah, green ant.
Oh, really?
We call them green ants down here, but in North Queensland, the proper Ecophylla are called green ants, the ones that nest in trees.
Yeah.
But this is a green ant from what Brisbaneites call a green ant.
And again, those colours are real?
Absolutely real, yeah. And this is that's a nasty carpenter ant. It's a big ant. And so the detail in it is astounding because you can see more.
I can't believe how sorry I feel for that man.
And this was a new species of robber fly named after Chris Burwell. And I took it with Greg Daniels, and it's an incredible thing. Those eyes are almost flat behind. They're not like rounded like a dragonfly. They're sort of, from the side they're thin, yeah. But you can see the Ommatidia, these simple eyes within the compound eye, they're much bigger in the middle, and you can see it's a predator. It's chasing things. And this one, it's just an example of how important it can be. This specimen is the holotype. So a holotype defines a species for all time. So it's biologically priceless. And then we keep something like 5,000 of the insect ones alone upstairs. And this was collected by my first boss, who sent me off for those 2 one-hour lessons in 1975. He collected it in 1959 on top of Mount Timbergargan, and a guy in Belgium wanted to study it. Well, it's priceless, and the auditors now value them at $20,000 replacement cost. You'd never get that for it, but that's what they valued replacement cost. And so I took 1,700 50 megapixel images to produce 5 views. This one took the most. I think it took 750 shots because he wanted a nose-on view. And I estimate I generated 3/4 of a terabyte of source images to make those 5 images, but it meant that he could study it in detail from Europe. And this is for a display. We did some New Zealand Powie shell, and you can almost see the crystalline structure there.
So that has been phenomenal with the stacked focus.
Focus stacked.
Focus stacked. So, and we've seen a lot of small things. How big can you go?
Well, when we first got this system in 2012, with money from the federal government, from the Atlas of Living Australia, we got a Hasselblad, a 200 megapixel camera, and we were able to take whole drawers of butterflies. And I started off taking pictures of the historic Dodd collection. This is a case of Ulysses from Alan Dodd's collection from New Guinea. And so that's zooming in on the one shot. And you can do that online on Google Cultural Institute. If you can find Queensland Museum on Google Cultural Institute, you can zoom right in online.
Oh, fantastic.
Yeah. So we also had volunteers take 850 drawers of images, of images of drawers, sorry. And I just want you to have a look, keep an eye on this little specimen. And this is focus stacked from Hasselblad images. And then we swap to the new microscope.
Wow.
And that's the other side.
Just showing off now, Jeff.
Yeah.
Rightly so.
I think that's it. Yes, that's it.
Fantastic. Well, look, I think you've got us all excited about colour and movement now, and I think we have to move on to pretty much everyone's favourite photographic object and the thing that landed you in the Tate, peacock spiders.
Yes. Now, I hope there's nobody that's badly arachnophobic. If you might want to leave now.
Do you want to cover your eyes? Yeah. Sorry. We should have meant to do a little...
They are, in reality, only about 3 or 4 millimetres long.
I don't think it matters.
But that's not going to help.
Let's just call them peacocks from now on.
Yes. So
This is not a peacock.
Yes. This is Maria Fernanda Cardoso, who's a Colombian-born artist of world standing. She's famous for her flea circus, of all things. But I first did some work with her. She used one of my drawings at the entrance to her Museum of Copulatory Organs in the Sydney Biennale in 2012. And So most peacock spiders, she got some money to do the first peacock spider images, and most peacock spiders, the males dance, and they dance with their abdomens with these flaps.
And that does just look like bad dancing from Jeff, but that is what they do.
Yeah, that's what they do.
It's not just dad
and they
moves.
also put their front legs up and things like that, and they there's lots of videos online. Probably most people have seen the one that's set to at the YMCA, which is pretty funny. So, but you can see they're tight when they're at rest. They're tightly wrapped around the abdomen. So, in 2014, my then volunteer Andy Wang and I used the old microscope system, which is the same one as I used on that wasp, and with a Canon 7D and a Canon 5D Mark II, which was 20 megapixel, and we positioned the specimens with pins or micro pins, and then we took lots of photos of them, and then I would Photoshop out the pins. And as we said, this is the artworks that Maria Fernanda made out of them, and they're called Actual Size. And she had these magnificent prints made of them, and they've been sold with money from Qantas jointly to the Tate and the MCA in Sydney, which is pretty special.
That's fantastic. Clearly the artist is not constrained by the need to have actual size mean actual size.
Actually on the print there is a little image of the thing at
really?
actual size. So yeah. Anyway, this is, then we had this big break, and we hadn't touched a peacock spider in all that time. In 2017 we got one specimen, nothing to practice on, and Andy came back. He was no longer my volunteer, and he managed to position them. And we did this one, and it became the image for the 2018 World Science Festival. Ah. But we spread the abdomen, and you can see those are on micro pins, so these aren't even full pins. And it was a small one, that's 0.5 millimetre. And we took that with the 5x objective. And then, because we only had a 20 megapixel camera at that stage, I took 12 100 stack images and merged them in Photoshop to produce this image. Mm. And that's after I Photoshopped out the dust and stuff, and after she had some professional deep etching done in Colombia, and that's the detail that's in the image.
Wow.
They're incredible things.
That's insane.
And then she was awarded a fellowship as an established artist for MCA in Sydney and University of New South Wales, I think, and maybe not university. Anyway, definitely MCA, Museum of Contemporary Art in Sydney. And so she had money to pay us to do more.
Fantastic.
And can you see why this one's called Elephants? Maratus elephants.
Wow.
It's amazing, isn't it?
Yeah.
And this is another species, Cristatus, and this is a video of it stacking now. That's the source image on the left, and this is the composite image building on the right. I hope everybody can see it.
Can you see it over there? Yeah. Wow. So sorry, how many stacked images to get that one?
I think it was 474 or something like that.
I mean, I lost count at about
yeah,
300.
Yeah, that's right. So we had to do, for the abdomens, we now had a 50 megapixel camera, so we did 2 stacks, in this case each of 273 source images, and then I merged them in Photoshop to produce pretty much close to 100 megapixel image for big printing. This one was slightly damaged. See this area here in the spreading. And we tried a second specimen spreading in a different technique, and it didn't work fully, but I was able to use bits of this one to repair the other one in Photoshop, and I was able to repair the card with Photoshop too. That's before and after. And you can see, sorry, wrong way. See this area here is fully repaired, and I deep etched it with an AI program to try and preserve all the hairs.
Wow. Okay, hang on a minute. I think we need a little. So you've taken us on a mammoth journey there, Jeff, from Byzantine times and way back, all sorts of methods, and even just the changes we've seen in the last few years. Now, you're not quite ready to retire. What are you excited about coming, the next changes, the next developments, and the next, I guess, uses for images like this?
Well, thanks. I've been really excited by what they've done with my images in the last few years. When we had construction work out the front of the museum, they printed some of my images 3 meters across. And this was a huge hit. And people, adults and kids, were standing in front of it and becoming a butterfly. That was really wonderful. I remember hearing a little girl as she was leaving the museum saying, "That's my favourite butterfly in all the world," and that was... yeah. And that's a phone panorama. It shows you the whole installation. They've put them on banners and things since then, but that was really amazing.
And you can buy some of the butterfly as a little mask at the gift shop later if you like.
Yeah, there's scales that are used as a pattern for a mask. And they also printed them 1 metre across and things. That was really exciting. And then they put them on the bridge. That was pretty amazing. But for the future, there's so many things happening. But one of the things that's affecting me particularly is these programs by Topaz that use artificial intelligence to edit your photos. My old boss, Jeff Monteith, who's up the back somewhere, and Jessa want to publish this image, and the only version we could find was only 600 pixels high, and I cleaned it up a bit in Photoshop, but you can see that's the detail that's in that image. And we've got these upsizing programs that use AI, and it's totally publishable now. So
wow,
it's really amazing. And the sharpening and things that they can do. We recently reprocessed an image taken from an old 35mm slide, all pixelated and looked terrible, and it just made it look like a proper photo. It was just great. So, yeah.
Wow. Well, I'm glad that's got you very excited. It's got me panicking because deepfake's not going to get any better with technology like this going. Right. But it's absolutely phenomenal. And just give it up, please, for Jeff Thompson. That beautiful story.
Thank you.
And we've got a big 5 minutes for all your questions now. I'm sorry about that. So I'm going to start with your question. Do you still have that, or it's been answered? It's been answered. Okay, it's been answered. Quick questions, yes?
All right.
So when you said deep etching within
Okay, and sorry, I have to interrupt because we're recording and live streaming, I have to stupidly repeat every question into the microphone. So because you said deep etching, what does that mean digitally compared to analogically?
It's putting something on a pure white background generally, or just no background at all that can be put onto something else. So when you've got a hairy insect, that can be quite a job.
And your question? Are you able to do that stack photography on live samples, or does it take too long?
It doesn't. It's not that it takes too long. It's that the things move. So any movement
Yeah.
ruins it. Yeah.
And yes? You've dabbled in so many different mediums, but which is your favourite? This is good because it also gives you a bit of
Yes,
time
I'm not
to
sure I
think.
have one. I love making these photographs. It gives you a huge boost when you come home and you've produced something that you're proud of. But I also love doing the etchings and doing hand-done work. So.
Yeah. Other questions? Yes, sorry.
So your focus area is on insects, but I guess with like anatomical images and medical images and things like that, did that follow a similar historical development? Like, was it the same sort of people who did those sort of images?
I think so, very much so. And I'm a member of the Guild of Natural Science Illustrators, and there are many medical illustrators in that group, and they're also moving with the times with all sorts of things like that.
Yes.
Will there be a role?
Oh, I forgot to repeat that question.
Uh-huh.
Do the same techniques apply, retrospectively, to the other kinds of illustrations that have been done throughout history? Yes?
My question will there be a role to play for, the drawn pictures as opposed to photography in the future of science?
Will there be a role for hand illustrations in the future of science, as well as all the incredible digital advances we're seeing?
Not so much hand illustration, but people drawing by hand digitally, very much so. But our mite people still draw by hand because it's very difficult to get the detail that's necessary, but that's sort of dying as things develop, get better and better.
Up the back?
Jeff, you started off by showing all the books from way back when. All the stuff you're doing now, where are the people in the future going to see that?
Oh, that's lovely. So Jeff started by showing all the books from historical times. The stuff that Jeff's doing now, where will people of the future be able to see that?
Well, that's a curly one.
I've got a crystal ball.
Hopefully they will still be able to be seen digitally, but the only way of really being sure that you've got a permanent image from a digital photo is to print it. And we do print them with on archival paper and things like that, with high quality inks that should last forever. There's one here which has been printed, and when they're properly done, they are fantastic. Yeah.
Okay, I see we've got a couple of questions still left. We're just going to sneak one more in. Yes?
Really quick, can printers keep up with the accuracy of the photos that you take? Do you lose detail in the print?
Can printers keep up with the accuracy of the cameras, the photos, or do you lose detail in the print?
When they're printed by somebody that really knows what they're doing, it's a whole science. I was lucky enough to go to a workshop in the Daintree in 2019 with Les Walkling, and he's very good at calibrating the screen, so what you see on your screen is what you get on the printer, and that's where I made that print. And in fact, that's probably as good as you're going to get off a screen. You just can't zoom in as closely. That's not really possible, but the detail that the printer can do is amazing.
That's so fantastic. Another hand for Jeff. Thanks very much. And please do come down and have a look at the originals of some of the works that we've seen here today. And Jeff, I know you're happy to answer any more questions, especially the deeply technical ones. Thank you so much for coming out again today. Enjoy anything you do with the World Science Festival. Stay safe. As they say, stay curious. It's been a real pleasure. We'll see you again. Thank you.